Good morning. Hope you had a very good evening yesterday. And we will start our today's presentation with Aggregated Monitoring, Chapter 1, RouterOS, by Bartlomiej from Poland.
Is this on? Okay, hello. So welcome to my presentation titled, as you can see, Aggregated Monitoring, Chapter 1, RouterOS. My name is Bartlomiej. I'm from Poland. I'm a network engineer with about 9 years of experience in the business. And, well, I'm a certified MikroTik fan, as you can see. So first of all, let's start with what is the traditional approach to the network monitoring, or as I see it, and what are its issues. So on the left, you can see the well-known systems for network monitoring. It's the Cacti, it's the Nagios, and SmokePing. What they have in common is that each and every one of them produces slightly different results. Cacti is mainly used for graphing. Nagios is mainly used for threshold monitoring, and SmokePing is for reachability testing, which is pretty standard. But the things that these systems have in common is that Cacti is using ICMP and SNMP to extract its data. It's mostly SNMP, but ICMP is used for reachability. The same case is with Nagios. Again, ICMP checks devices whether they are reachable and extracts data for its threshold monitorings. The SmokePing only uses ICMP because it only tests reachability, but you have three different results taken from the same checks, so it's really rather inefficient. On the right, you have a more aggregated systems. The Zabbix, Observium, and Libre NMS. I'm sure you know the logos. The thing is, each and every of those systems on the right is capable of performing all those three types of checks, so graphing, threshold monitoring, and reachability testing. But the issue is that each and every of those systems has to do all the job from A to Z, from data extraction to processing to displaying it. And this may at some time become a bottleneck because of, it may be difficult, at some point it may be difficult to scale the workload on those systems. One other thing that all those systems have in common is that they need full network reachability. So each and every one of those systems has to be able to access via ICMP or SNMP or whatever each and every system that it monitors. And again, if your network grows or becomes somewhat complicated, it may become a problem at some point. Really, that's what I don't. These are the main issues that I see with standardly available network monitoring systems. And so, what do I want my system to be able to do, or my favorite system to be able to do? First of all, I want it to be able to do everything. So, graphing, thresholding, and reachability monitoring, all in one place. That's the one thing. The other thing is that I would like it to be. Sorry. Sorry, I was too quick. Let's skip that. Let's just remember that with a standardly used monitoring system that is available off the shelf, you have to really accommodate yourself with the way a system monitors a network. You have to accommodate yourself, your network monitoring requirements to that system. Let's go to go again to what I believe a good monitoring system should do. So, as I've said before, full aggregation, all checks in one place. Also, I want flexibility from the system, meaning that I would like to be able to add any types of checks that I currently require within minutes or hours at most. And by checks, I mean standard SNMP data extraction and CLI data extraction, which becomes handy from time to time. I also need good scalability of a system, so I want it to be able to scale up and scale out easily. And the last thing I want from a monitoring system is that I want extreme simplicity of a system, meaning that it should be able for every person that wants to use the system or expand on it to be able to learn it quickly, do not need any skills in coding techniques whatsoever, just very basic, simple stuff. And so, in summary, I want a monitoring system to be able to perform graphing, threshold monitoring, alerting. I want it to have good performance. I want it to be manageable and extensible. And some time ago, I did a sort of market check to see which system readily available to use as a base for my approach to network monitoring. And after some consideration, I chose the Nagios and the PNP for Nagios plugin, chiefly because it's very simple to, it's very configurable. So it's easy to, it's easy to really make it do everything. So this was the base of the system, and so the Agmon, as I call it, system was born, which used first of all, the standard features that are available with Nagios and PNP for Nagios. So graphing, PNP for Nagios handled that. Threshold monitoring and alerting was the responsibility of the Nagios core. And as far as extensibility goes, at that time, I mainly used the check and SNMP standard sensor available with Nagios to address these or those of each and every of my network monitoring requirements. I also employed some custom bash scripts for extracting data that needed some further processing. Like, for example, if you have a UPS device and it shows its battery runtime in centiseconds, which is really rather strange. You would like to have it in minutes or in seconds, and that's what the custom bash scripts did. It extracted data, processed it in flight, and turned it into something meaningful. I also used even more custom bash scripts, like, for example, when I had to check the power supply unit's states on an SDH network management system server. And the only way to check those PSU states was to actually log into that server and see whether they're up, down, or in some fail state. So this is an example, this is an example of even more custom check that it already is. On top of that, I created a script that I called the Grand Unified Gatherer. And what it did, it handled all network discovery, it handled sensor setup, it handled sensor updates. So if you add or remove a card to or from a switch, a bigger one that is, then it updated those sensor information. And as far as performance goes, well, to a certain extent, everything was fine. But then when we reached 20,000 sensors, you can see it's about 2,000 points of system load at the peaks. And, well, this leaves something to actually wish for. So certainly there is some place for improvement. When it was 16,000 sensors, it was okay. But now, while it's 20,000 is, well, it could be improved on. I just didn't know how just yet. So it was about a half year ago. And at some point of time, more or less 4 months from now, back from where we are now, I had this conversation with a colleague. I told him that, hey, I'm developing this really, really great monitoring system, so I would like to poke your devices with SNMP walks and SNMP gets. So can I do that? He looked at me and said, well, no way, you cannot. But what you can do, you can use a statistics broker that is available with my device's central management system and use this data. And this gave me an idea about, well, so what can I do to get a statistics broker? And, well, I made a mental breakdown of what a monitoring system actually does. And, well, what it does is device discovery and identification, which is obvious. It sets up sensors, retrieves and processes data, presents this data to a user or administrator, and stores it for historical usage, like with a graph. where does that fit in with, how does that fit in with my old Agmon approach? Well, you have a centralized system that does pretty much everything, and exclamation marks show you how much processing power each and every one of the constituent parts of a network monitoring process took. And you can see device discovery and identification took the most. Data retrieval and processing took the, well, pretty much the same, but in a more distributed way. Data presentation, historical data storing, no workload at all. And actually, what you can see here, the biggest load is what you can actually see here, because it's when well, each and every of those peaks means that the data were being extracted for the sensors that have already been set up some time ago. But also there is a new rediscovery process taking place. So here is the enemy to the load. Okay, so let's go back to where we are. So I had a system that required a lot of computing power and a lot of storage. And I was thinking how to address that. And I devised a new class of system that would be a part of the Agmon infrastructure. I called it the distmon. So we went from aggregated monitoring to distributed monitoring sort of way. And I took away all those, the most processor-intensive processes away from the Agmon device and transferred it to the distmon device so as to share the load. So the distmon device became a system that only extracted and processed data and then transferred it back to Agmon for presentation and storing. In that way, I removed, as far as load sharing goes, the Agmon system still requires a lot of storage to store the data, but the processing power is not that important. This is important for the distmon system. And okay, so how did I get to the distmon system? And I wanted it to be very simple, extensible, and easy to use. So I use the Linux as a base for the whole system. I use the Born-Again shell, which is standard Linux available shell, as the code base. Everything is written in Bash from start to finish. I use standardly, easily available data processing applications that are available with each and every Linux for string comparison or string manipulation, this sort of stuff. I also required some applications to retrieve data from devices, so ping for ICMP, NetSNMP for SNMP data extraction. I also used OpenSSH, and SSH does the part of data extraction via the CLI, and SCP, which is a part of the SSH package, does the data transmission from the distmon system to the Agmon system. And since the Bash shell isn't capable of handling really, really big numbers, so counters 64, this sort of big numbers, and it's also incapable of doing floating point calculations, so I employed the Linux BC calculator to help Bash with the difficult calculations, let's say. And since the system was designed to be more than one, it's distributed after all, so I needed some type of version control system, and I chose Git and GitHub for keeping the code synchronized across devices, so distributing updates, changes, new sensors, and so on. And so the mental breakdown of what a system or monitoring system does has been addressed by the following scripts. I have the first discovery and identification, which is done as the first, is handled by the runner script. Data retrieval is handled by the Rover script. The processing of data is handled by two scripts, regulator and presenter. Sensor setup, and this is on the Agmon system, is handled by the gatherer. And data presentation and historical data storing, it's done with Nagios as it was with the old Agmon solution. So let's go to a quick display of how the system is constructed. So we have reusable functions and reusable variables that I have put into a separate set of files. Each and every of the scripts that I've shown you are using some of or all of those functions. So each script is able to gather those functions, so not to copy all the functions to one script and put them in the other and so on and so on. We have one file for sourcing by each and every of those scripts. And the scripts operate in a fashion that they take some data, either processed by another script, one that is run previous to it, or data extracted from a network. It performs some operations on the data, stores it, and then a script stores the data for another script to take the data, process it some more, store it again for the use for the next script, and so on, from start to finish. Also, one of the scripts is employing subscripts to process this data, but we will get to that later on. So let's start with the runner script. It's very, very simple script. The one thing it does, it discovers, first of all, it takes the list of devices it should discover. It can be taken from an Excel file, from the DNS domain, from database. However you like to store your information about your network, you are able to extract it easily. You are able to provide it to the Distmon runner. So it does an ICMP reachability test. If a device is reachable, it then tries to see if the device responds to any of the community strings that have been configured with the system to use. And if a device responds to one of the communities, it takes its system description, so it identifies the device, stores this information away. It also tries to see if there are any SSH login plus key pairs available, so that whether the device is available for CLI monitoring or not. And if it is, it again stores this data. And once the data has been gathered and stored, the system sends, with the help of SCP, all the gathered data to the Agmon system, for the system to then be able to set up new sensors and new device checks. We'll get to that later on. But the second in line, one important thing to remember with the script is that if a device cannot be discovered and identified properly because it's unreachable at the moment, like it has a downtime or a failure, it will not be processed by any other scripts in the line until the runner discovers the device properly. So if we run a second invocation of the runner script, the device gets discovered, it then gets processed by the other scripts. And we go over to the Rover script, which takes the list of the properly discovered systems or devices. And it does two things. First of all, it extracts SNMP data that should generically be provided by each and every device, like interface traffic specific data. So each and every device is asked for that data. And depending on what a device is, whether it is a RouterOS device or a Cisco switch or whatever, the script then asks for data specific to that system. Of course, it is configurable, and if you want to add a new device, or if I want to add a new device or a new check to the system, well, it's a simple condition statement. If a device is this or that, walk this or that SNMP branch. If it's a different device, then walk some different SNMP branches, as easy as this is. And then having finished its job, the workload is transferred to the Dist1 regulator, which is by far the fastest of all those scripts, and it requires absolutely no network interaction. What it really does, it converts the raw SNMP data that has been extracted by the SNMP bulk walks of the previous script and transfers it into outright bash variables for the next script to source. So the sole purpose of this part of the system is to make really bash variables, nothing more. That's why it's so fast. And once we have everything converted into, or all data converted into bash variables, we can then use the presenter, which again sources the data, it's bash variables at the moment, quickly identifies what sort of data is it dealing with, and spawns a certain subscript to handle this data. So if we have data for interface traffic, and so on, it spawns as a subscript that deals with computing interface data. If it's dealing with a RouterOS device, so you have queue tree or simple queue information, it spawns a script that handles just that. If it's a Cisco, it spawns a Cisco script. If it's Juniper, and so on and so on. Once it's finished, it does really one thing. It takes all the data that has been distributed into a specific set of files, some for interface traffic, some for just some other information, and sends that away to an Agmon system for further processing. And by far, this part of the script is the most complex one, because it's the only one at the moment employing subscripts to do its job. But since it's designed to use subscripts, if you want to add some new functionality, you just create a new subscript, so you don't add any complexity to the whole script itself. So it's still very, very simple, very, very extensible. And once we have all data available, pre-calculated, and so on, we go to the Agmon system, where the gatherer script resides, and it browses the catalogs that are holding and receiving constant updates from the various distmon systems. And basing on the data that it can find there, it generates Nagios-specific sensors. So devices, interface traffic, queues, wireless information, whatever. As you can see, we go from text-based data, pre-calculated data, into the actual Nagios sensors. So with graphs, without graphs, anything. And to show you some use cases, these are not the only ones, but just to give you an example, let's imagine we have a network, and we employ two distmon systems with ICMP and SNMP monitoring. And one of the distmon systems handles only half of the network, the other one handles the other half of the network. And they calculate process data, and send it to two Agmon systems for redundancy. So even though each and every of the distmons only sees half of the network, and we have configured them to only see this part. One handles only access points, the other handles only cloud cores, or the other handles some different devices. We are able to have full network visibility on both redundant Agmon systems. And but the downside is that if we lose one distmon, we lose half of the network's visibility. But again, this is not the only use case that we can employ. A more complicated one is with unbalanced data processing. So we have one distmon doing all ICMP to the whole of the network, and doing SNMP checks to most of the network. It doesn't check this device. We have another distmon that is only doing ICMP to all parts of the network, and a third distmon that does SNMP to all parts of the network, and it also does some CLI data extraction and processing from a different device. And again, they all distribute the data to the Agmon systems for full network visibility. And so there's some redundancy employed, because let's say if you lose this distmon device because of a failure, you still have ICMP reachability data of this part of the network, because it's being handled with the other distmon server. But on the other hand, if you lose this server, the data extracted via the CLI is being lost, because it's the only one. And these two are really the only example use cases, because the system is flexible, able to handle any kinds of setups. You make the choice and set up the systems however you like. You can use each and every model. You can use all modules of the system, just a few modules, one module, whatever you choose. And my favorite use case is, let's suppose you bought a network from a different operator. And it so happens that this is your home network. This is the network you've bought. And you have the same management addressing space, so it's overlapping addresses. So it's not really that easy to integrate that. You have to think of a solution. But if you want to have full network reachability, or if you want to have a full network view, what you do is that you deploy Distmon servers within the newly bought network. They do the processing of data, the discovery, all this sort of stuff. You then SCP this data over via a NAT gateway at the new network. It goes over the internet to your NAT gateway, and then you DST NAT the data to your home Agmon servers. So in fact, you get full network visibility of full network monitoring with a system that you already use for your network, even though those systems have no way of contacting those devices for data extraction, which I think is really great. As far as performance goes, well, in this use case, we have the Distmon rover. It took 11 seconds to complete its run, and it takes some time because you have to send SNMP bulk walk all the data you want to extract, and it takes some time. With the regulator, it only took 3 seconds to process 20 devices, which is really rather quick because it's only a string manipulation. And with the presenter, it took 8 seconds to count 1,107 objects, and we'll go to what an object is in a second. But the time span is about 0.0072 seconds per object, which I think is really rather great for a bash assisted, with a bash script assisted with a BC calculator. Also, the load isn't that big, and it's being kept in check by only spawning a number of concurrent processes for doing data processing. As far as the performance of the Agmon system goes, well, you can see that the service and host execution checks take almost no time at all, and it's precisely because the Distmon server has already pre-calculated all the data, and what the Agmon server only does, it takes the data and puts it on the graphs or into the threshold monitoring sensor as it is. No processing is required. And also, check this out. We have 3,400 sensors, more or less, and only 1,000 objects. And how does this happen is if you look at a standard interface data that has been extracted from a device, from a switch by the Distmon system, you have about 20 or so lines providing you with different data. And so with this, using this one object file, you can actually address, in this example, I have 5 sensors that are being addressed with this data, but you can have more. You can do graphing with the data provided here, interface up and down statistics because the information is here. You can do error checking per interface. The data is available. Same with interface utilization. You can see a 1.35 gigs of traffic on a 10 gig link, which amounts to about 13% of interface load, so you can monitor that. Also, if you are interested in spanning tree transitions per interface, you can also have a sensor to get this data because it's available here. So it's like a 5-to-1 ratio. You do one walk of a device, you get this many data, you can address 5 sensors. So I think this scales pretty well. And as far as and you can see the graphs over here. Since we have that much data and we are able to readily use it, we don't have to extract it all over and over again from a device. I am able to create as many graphs as I really like. So I have traffic in and out, unicast packets in and out, multicast packets in and out, and broadcast packets in and out. So if you have an interface that is even doing about 500 megs of traffic, and if it's a normal condition, you can learn that you shouldn't allow for more than about 30 broadcast packets per second. You can then set up your threshold monitoring accordingly and alarm you about the threshold crossings. And as far as CLI management, CLI monitoring goes, this is an example of a wireless client of a RouterOS access point. And this is all the data that you can get from a CLI, from RouterOS CLI informing you about each and every particular client. So you get TX and RX CCQ values per client, not per the whole access point as you can get normally from the RouterOS SNMP information. Well, you also have to do some calculations because if the information is provided in bytes and it's an incremental, like with the SNMP counter, you just have to do some recalculations. Also, if you want to learn about the uptime, you have to, well, you have to be creative with that, and I've been creative. It's just string manipulation that turns this data into seconds. And again, you have this many data, and you can set up any sensors that you wish for monitoring the customer. So let's say if you want to see signal to noise versus CCQ versus, I don't know, signal strength, you can set up a sensor doing just that. It's one go of the script and that many data for you to use. And to see the graph of a specific RouterOS client device, you can see traffic, you can see TX and RX CCQ because, well, the client is either a RouterOS or the other vendor's device that is able to communicate the data, which is Ubiquiti, of course. You have the negotiated TX and RX rate, TX and RX signal, signal to noise, and uptime of the link. And this is the data which I find usable, so I plot the graphs for such data. And I think we are done with examples. So maybe, how long did it take me to get from the initial idea of the one Agmon system to a distributed idea of Distmon and Agmon system and to the point where I am now? Well, it took me about more or less 4 months, and I'm just one guy, 4 months of honest labor in my free time, and by honest labor I mean 8 hours of doing just this project. So it totaled to about 1.5 years, about 4 months in total. And I think I have addressed all the issues that I had with the standard systems. So I've addressed efficiency. I do one walk of all the devices. I get a wealth of data for processing. So that's one thing. I've addressed reachability because, as you've seen, the Agmon system is not really having to be able to access each and every device it monitors. And I've also addressed the scale up, well, not maybe scale up, but the scale out problem with the employment of the Distmon server, which I can spawn as many instances as I need and monitor as big a network as I want it to be, as I have. Well, so I did it all, but you also can do it. Well, because I've told you, it's one guy, it's bash coding, no fancy techniques, simple stuff. You just need to have some time and use proper ideas to do that. But the work does not stop here. There are a few plans for the future. One of them is well, Nagios has a standard network graphing system. It's really bubbly, it's really bubbles and strings, but it's very clear, very performant. And since I have already got all the data extracted from all devices, I can use that data to then plot a map. It's not a real map, it's not really working just yet. I have a developmental version which graphs something, but not all. It's a work in progress. The next plan is to get the Distmon systems to store all the gathered and processed data in some sort of NoSQL database, so a MongoDB or CouchDB or whatever. and to become a proper data statistics broker, and then to be able to provide this data to Agmon as it normally did, but also to be able to provide this data to some commercial monitoring system, so that this one is the statistics broker for any other system that is capable of taking data from a database, and also maybe to a big data engine if there's ever a need to process loads of data from a network. The next plan is to aggregate the Agmons under the umbrella of a third Nagios plugin, which is to get full network visibility from a few different Agmon systems in one place, because this is what Thurg does. And well, the last but not least, maybe create some proper documentation for the whole systems, because at the moment it's all in my head with some slight comments in the code, but that's it. And maybe to get someone to help me with development, because as I've told you, I'm just one guy. Do we have some time more? Let's see. Oh, okay, we still have some time, so let's go to a live demo. And the live demo is really the third use case, more or less, that I've told you about. We have an Agmon system that is located in some external network. We have data being extracted from devices on a totally different network. One thing that I'm missing is that I'm extracting data from the CLI, but it's not shown in here. So the data gets extracted by the Distmon systems and sent over to the Agmon system, as I shall now try to demonstrate. Okay, so we have the Nagios as the base. There is some load, I think, but not that much. We have 25 hosts added to the system, different kinds of hosts, some Cisco switches, some routers. And what you can see is that I am able to plot ICMP reachability tests, even though the system, the Agmon that is displaying this data, does not have system reachability. Well, the data is being fed to it by the Distmon system, so it's able to monitor a device for reachability. And let's go over to some traffic monitoring. So this is what you've seen before with a slide. We have some data. We can see some heavy user doing 6 megs at this time. And it's only really unicast traffic because we have almost no traffic with multicast and no broadcasts, which is a good thing always. And let's see some service groups. Well, it's all my work. I grouped the tests into different, let's say, groups for better management. And let's go to some wireless access point clients. We have a few. There are many more, but I have only those. I have only a few added. Those in the yellow, so unknown states, are those that have been discovered some time ago, but have not been connected for at least 5 minutes. So the data became outdated, and the system marks it as such. And let's find someone who's using the link. Like someone just started, because it's live data, so someone was using the link. We have the connection quality, we have the rates negotiated, and so on and so on, all the data. The link has been up for 139 hours, which is quite a lot. It totals to about 6 days. What else to show you? And please remember, the Agmon system still does not have any sort of connectivity to those systems. It relies on data provided to it by the Distmon system. Let's go to something else like CPU load. And this is this is a cloud core router, as you can see from the interface names. We have CPU load, which is the overall CPU load, as you can see with your Winbox. But if we look under the hood, and I will try to get under the hood data in just a second. Okay. But if we look under the hood of the actual test, is that it's not really that clear, but you can see that it is a RouterOS 6.32.3 on a CCR with 36 cores. And you have all the cores denoted in here. So the first one is doing 5%, one of them is doing 92. So really not much job, but this, I don't think you are able to see it, but this totals to about 2% of load at the moment. And it's the only data I am displaying and graphing at this time, but give or take 5 minutes and I'm able to plot all this data on the graph. We will have a really mess because, well, it's 36 processors, so it would be a mess, but it's doable if you require that. Also, I have the I calculate the memory percentage of the system and so on and so forth. Well, it's don't think there's anything more that's really fancy with this system anymore to show you at the moment. Maybe if we had a look at the access points, this is actually the access point at my home. Since I'm not there, so the not much to show at the moment, but I have some data when I was indeed connected with a mobile phone or with a PC. So this is a graph. I'm using the 2447 megahertz channel, and this is actually data that is available as is from the SNMP of router-specific MIB file. So this is the data from an access point, and well, this is the dashboard again. So again, the system, the actual Agmon system that is shown to you in here is only able to reach 2 or 3 devices over a standard SNMP, over the standard internet access. But even though it can access those 3, it still relies on data provided by distmons, and distmons are able to access all the devices. And I think that is it. If you, I don't know, maybe have any questions about the system.
Thank you. Questions? Okay, then thank you, Bartlomiej.
Thank you very much.
Our next presentation will be about NetFlow. What happens in your network? By Lorenzo Bussati from Italy.